Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see problems on longitudinal displacement, means how to find the longitudinal displacement. So this is our lecture topic, that problems on, one is the problems on longitudinal displacement. Okay, so just see here the question. A symmetrical panel has the form shown in figure here. That form is there. The longirons are of constant area. So longiron having that constant area from here to here, that is given B. Okay, area B1 for the edge member and B2 for the central member. So this one is here just right. So B1 is the edge member and B2 for the central one. Okay, and the seat is of uniform thickness T. So their thickness is uniform overall, or just this is just converted this one. So uniform thickness from here to here, that is T. The panel is assembled without stress. So the panel is without applying any stress, that is what assembled. Just or you can say one over the another is kept. Now here, this is the question. Obtain an expression for the distribution of end load in the central longiron if it is then raised to a temperature T. Now what happened? Now after just keeping, you have to find the stress distribution, that distribution of end load when that is raised by a temperature T, constant along its length, above the edge member, whatever is there, just raised by T above the edge member. Also give the longitudinal displacement here, that is fine here. Longitudinal displacement at one end of the panel of the central longiron relative to the edge member. So relative to the edge member from the central, means relative to this, we have to find for the central longiron how much the lower longitudinal displacement will be there. So this is up to the question. For that constant, what is given? So just here, assume that end loads are carried only by the longirons, that the seat carries only shear, and that transverse member are provided to prevent transverse straining and to ensure shear effectiveness of the seat at the end of the panel. So at the end of the panel, there is, that means only they have the shear stress, right? And the transverse member are provided to prevent, means what? This prevent to straining, means this is not getting strained, right? So here, or simply in simple word, this side is not getting any effect. So only here over the surface that we have to find. Okay, so now let's see the solution. The panel is symmetrical about its vertical center line. Therefore, each half may be regarded as a panel with a built-in as shown in figure. Right. So here, this is just along the vertical also is symmetrical. Right. So further, the panel is symmetrical about its horizontal center lies, so that only the top half need to be considered. Now, just here. Therefore, the half may be regarded. Okay. The panel is symmetrical about its horizontal center also. So along somewhere here, that is also symmetrical both the sides, right? So just upper half considered. That upper half means lower half also will be the same. So what we have to do? Only we have to consider half. The assumed direction of the shear flow are shown. So how that is there? So just see from the top. Okay, this is for this one. Consider the equilibrium of the element of longiron 1. So for here, longiron 1 is showing. So just see here that here in this direction P is acting. So opposite direction P1 plus del P1 by del Z into del Z. That already we had seen that in one question. So this is for P1, and this area, this length is what? Del Z. Similarly, P2 in this direction, and just see here Q, that's here is here in this direction. Now in this second, right? Okay, that P2 is acting here, Q is acting in this one also, and Q is acting here also. So in this case, 2Q is acting, and here only the Q is acting in this direction, and this is P2 plus del P2 by del Z into dz. Now what happened for equilibrium? All the forces acting on that must be equals to 0, right? So means based on the direction. So this direction we are taking as positive, so this is negative. So what happened with that? P1 plus del P1 by del Z into del Z, okay, or del Z minus P1, and then just see here in this direction it's acting. So it's in this direction Q is acting, so means it's negative. So Q into del Z, that should be equals to 0. So from here P1 will get cancelled. So from here what we will get? P1 is not there, del P1 by del Z into delta Z minus Q del Z equals to 0. So from here what we can find? Del P1 by del Z into delta Z equals to Q into delta Z, right? Delta Z cancels. So what we will get? Del P1 by del Z equals to Q. Okay, from the first figure. Similarly, for second figure, what we can do? Everything will be same. Okay, so for the second figure, what will be there? Similarly, P2 plus del P2 by del Z into dou Z, right? Minus P2. Now just see here. Both Q is acting in this direction. So Q plus Q del Z plus Q del Z, that is equals to 0. Right. So P2 will get cancelled. Here del P2 by del Z into dou Z. Right. Then plus 2Q dou Z, that is equals to 0. Now take this to this side. So del P2 by del Z into del Z equals to minus 2Q del Z. So this del Z cancels. So what we will get? Finally, after this we will get what? Del P2 by del Z equals to minus 2Q. Okay. So now we got. See, as I say, del P1 by del Z equals to Q. Now consider the equilibrium of the element for longitudinal 2 shown in figure. So from this case what happened? P1 plus P1. So 2P1 plus P2 equals to 0. Right, the total force should be 0. So from here, now from the compatibility condition, this already we had seen. This one also, the similar equation will be here, the compatibility. Just we have to replace the value. The compatibility condition for an element of the top half of the panel is shown in figure of the top half. So here, and this will be what? 1 plus epsilon 1 into del Z. Here, this angle is gamma, means this angle will be what? Gamma plus del gamma by del Z into dou Z. And here is 1 plus epsilon 1 into del Z. So here this will be 1 plus epsilon 2 into del Z, and this is just given as D. Now from the compatibility equation, so this will be equals to what? This plus this one. So just see 1 plus epsilon 1 into del Z here, that is equals to 1 plus epsilon 2 into del Z plus D into D gamma by dz into, or del gamma by del Z into dou Z, this one. That is, from here what we have to do, just take this side and we have to find D gamma by dz. So see, after multiplying here what we are doing, just multiplying. So del Z plus epsilon 1 into del Z equals to what? Here this will be del Z plus epsilon 2 into del Z plus D into D gamma by dz into del Z. Right. So now take these two terms this side. So after that what we will get? Del Z plus epsilon 1 del Z minus epsilon 2 del Z, that is equals to df d gamma by dz into del Z. Right. So here del Z get cancelled. After taking this delta Z common, what we will get? Epsilon 1 minus epsilon 2. This is D, not differentiation D. Okay. That is equals to D into D gamma by dz into del Z. So this del Z get cancelled. And what we have? Epsilon 1 minus epsilon 2 equals to D into D gamma by dz. So from here what we will get? D gamma by dz equals to 1 by D epsilon 1 minus epsilon 2. So that is here. D gamma by dz equals to 1 by D into epsilon 1 minus epsilon 2. Fourth equation. Now in fourth equation, put epsilon 1 equals to what? P1 by B1E. Okay. And also gamma as equals to Q by dt, that already also we had seen. So from equation 2 what we will get? Q equals to minus del P2 by del Z by 2, because there we got what? Del Pz by del Z equals to minus 2Q. So from here Q will be equals to what? Minus 1 by 2 del Pz by del z. That is here. The q equals to minus 1 by 2 del p2 by del z. Now substitute here, right, for the value of q, and then q in equation 5 for p1 from this one. So after putting the value, what we'll get? So just see this value, q equals to minus half del p square, because del p by del z is there, right? So differentiation of this term once again. So minus half del square p2 by del z square equals to gt by d. D is taken common, right? Minus p2 by 2b1 minus p2 by b2 minus alpha te. So here this term is increased because of what? The temperature effect, and alpha is the temperature coefficient. Or so just after simplifying this one, right? So take these things one side and alpha t, that this term other side. So del 2 p square, or taking this to this side and this 2, means this term to this side 2 equal to, and this term that multiplied by this to this side. So this term becomes positive and this also becomes positive. So del 2 p by del z square minus, after multiplying 2 gt by d into 1 by 2b1 plus 1 by b2, that is equals to 2 gt alpha into t by d. So this is 6. Now what is that? So this is just t, this is in the form of differential equation. So now what we have to do, we have to solve by the differential equation method, right? So the general solution of this will be what? P2 will be equals to c cos h mu h plus d sin mu h, d sin h mu z minus 2 gt alpha t by mu square d. So whatever this side is there, that is constant. Now here what we have to do, because just this should be free from this one, where mu square equals to 2 gt by d. So this mu square is 2 gt by d into 1 by 2b1 plus 1 by 2b2, because this divided to this one. So now we have what? This equation. Now for finding the p, we need to substitute the value of c and d. How we will substitute the value? Find d, c and d by the boundary condition or int condition. So now just apply the boundary condition. So when z is 0, p2 is 0. So that from equation 7, right, just put here, when what? Z is 0, p2 is 0. So 0 equals to c cos h mu into 0 plus d sin h mu into 0 minus 2 gt alpha t by mu square d. So now when this multiplied 0, sin 0, 0, so this term will be 0. Cos 0 is 1, so c. So c minus 0 equals to c minus 2 gt alpha t by mu square d. So from here what we can say, c equals to 2 gt alpha t by mu square d. So now we have the value of c. Next what? We have to find the value of d. Once we have the c and d, let's put in this equation, you will get the final value of p. Also when z is L by 2, q is 0, and from equation then again substitute to del p2 by del z is 0. Hence from the equation this 0 equals to mu c sin h mu L by 2 plus mu d cos h mu L by 2. So from here just now put the value of c, right? Then d, our d will be what? Just here. So mu d, I am solving this one, mu d cos mu L by 2 is equals to minus mu c sin mu sin h mu, here also h is there, L by 2, right? Now just put the value of c, or simply here mu. So first d will be equals to what? Mu and mu will get cancelled, right? Both side mu is there. So d will be equals to c sin h mu into L by 2 divided by cos h mu into L by 2. Now so d will be equals to this sin by cos, that will give tan. So c tan h mu into L by 2. Now put here the value of c. So d equals to, c is what? This one. So this is minus, right? So minus. So minus c is 2 gt alpha t by mu square d into tan h mu L by 2. So just here. Now we got d equals to this value. Now once we have d right? Just put C and already we found C, so C and D substitute in this equation, right? So after that what we will get? P2 equals to, after taking 2 gt alpha t by mu square common, mu square d, what? Cos h mu z minus tan h mu l by 2, right? Into sin h mu z minus 1, just after substituting the value of C and D minus 1. Or substituting for mu square, just substitute the mu square value also. Then what happened? Just that will get cancel, and finally what we will get? P2 equals to E alpha t into cos h mu z minus tan h mu l. So tan h mu l. So just P2 will be equals to what? E alpha t into cos h mu z minus tan h mu l by 2 into sin mu z minus 1 whole divided by what? 1 by 2b1 plus 1 by b2, right? So this will be the P2 formula. Now from the figure 4, the relative displacement of the central longiron at the end of the panel, what? D of gamma z, that is equals to 0. Hence gamma z is 0 means q by gt at z equals to 0 is equals to gamma at z equals to 0 is q, gamma is q by gt, already we substituted. So gamma at z equals to 0 is equals to q by gt at z equals to 0, that is equals to what? Minus 1 by 2 gt del p2 by del z at z equals to 0. This is from here, from equation 2. Now just substitute this value. So hence from equation 9, right? Relative displacement will be equals to what? Alpha t by mu into tan h mu l. So this is the final what? The force that according to the question, first part, what is required? Yeah. No. Expression for distribution of end load. So distribution of end load is here, and next what is that? Longitudinal displacement, or you can say the relative displacement. So relative displacement will be equals to alpha t by mu into tan h mu l by 2. Okay. So this will be the final equation of relative displacement, or you can say the longitudinal displacement. Relative and longitudinal both are same. Okay. So this is again just you can refer the Maxim book for this derivation. Okay. So if you have any doubt regarding this derivation or anything, you can just comment on the video or you can contact me. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.